Hi students, I'm Praveen Sebastian Paul. In this lecture we are discussing the example number 3 for the Boolean function simplification using 4 variable K-map for SOPs. So in the last 2 lectures we had discussed 2 examples for the 4 variable K-map solution, and in the lecture number 71 we had discussed that the detailed rules for reducing a K-map. So my dear students, these rules includes pair reduction, chord reduction, octet reduction, map rolling reduction, overlapping group and redundant group reductions. So my dear students, before going through this lecture, kindly watch the lecture number 71 for detailing of these reduction rules. So my dear students, in this lecture we are considering our third example. Our question is, simplify the Boolean function a dash b dash c dash d dash plus a dash b dash c d dash plus a b dash c dash d dash plus a b dash c d dash using 4 variable K-map. So while examining this given function, this function has 4 different variables, that is a variable a, b, c and d, and we can see that all the individual terms of this function has all these variables. Thus, the given function is a complete function, and if it is not a complete function, we should ensure that all of the individual terms must have all these variables. So here in this question, the given function is a complete function. So next what we have to do is convert this function into the binary representation or minterm representation, that is a dash, b dash, c dash, d dash can be represented as 0, 0, 0, 0. A dash, b dash, c, d dash can be represented as 0, 0, 1, 0. A, b dash, c dash, d dash can be represented as 1, 0, 0, 0. And finally, a, b dash, c, d dash can be represented as 1, 0, 1, 0. This simply means that a variable can be represented as 1 as well as a variable complement or variable dash can be represented as 0. Here in the next step, what we have to do is 0, 0, 0, 0 can be represented in minterm as m0, 0, 0, 1, 0 in minterm representation is m2, 1, 0, 0, 0 is m8 and 1, 0, 1, 0 is em10. So the given function can be reduced or can be represented as m0 plus m2 plus m8 plus m10, or sigma of 0 to 8, 10. So here in this question we can see 4 different variables. Therefore we are using 2 raised to 4 cell K-map, that is 16 cell K-map. That simply means that K-map has 4 rows and 4 columns, and the row represent the variable a and b, and the column represent the variable c and d. So next what we have to do is mark the binary number 1 for the minterm positions, that is the minterm m0, m2, m8 and m10 can be represented in the K-map by representing or marking 1 in the cells 0 to 8 and 10. So we have to represent or we have to mark the cells 0 to 8 and 10 with 1, and all the remaining cells should be marked with 0. Thus the K-map will become like this, and in the next step what we have to do is pair these individual minterms. Here we can make a combination or we can group the different minterms by applying the map rolling reduction rules for marking the code with the cells 0 to 8 and 10. That is, the code can be marked using map rolling with the row 1 and row 4, and with the column 1 and column 4 with the cell values 0 to 8 and 10. This code can be reduced as b dash d dash. The reduction comes like this. Since this code has the row values 0, 0 and 1, 0, that is row 1 and row 4, if we are considering the variable in the row 1 and row 4, the value of the variables are 0, 0 in the first row and 1, 0 in the fourth row. That is, the value of the variable a is changing from 0 to 1 if we are moving from the row number 1 to row number 4, and the value of b remains unchanged with b is equal to 0. Thus we can consider the variable b into the reduced form. Here the value of b is 0, thus we are taking it as b dash. Similarly, if we are considering the column 1 and column 4, the values are 0, 0 and 1, 0. That means that the value of c is changing from 0 to 1 and the value of d is unchanged with d is equal to 0. Thus we are taking d dash. Therefore, the code can be reduced as b dash d dash. Therefore, the SOP for the given function is b dash d dash. So the function a dash b dash c dash d dash plus a dash b dash c d dash plus a b dash c dash d dash plus a b dash c d dash can be reduced as b dash d dash. So my dear students, hope you had understood this topic. So my dear students, kindly go through this assignment question. Our question is, simplify the Boolean function using 4-variable k-map with the function f of d, e, f, g is equal to sigma 0, 2, 3, 8 and 10. So my dear students, hope you had understood this topic. So in the last 9 lectures we had discussed the k-map solution for SOPs with the 3-variable and 4-variable k-map reduction methods. So hope you had understood this topic. So my dear students, we will discuss in the next set of lectures with POS solutions. So see you soon. Until then, goodbye. Thank you and all the best.